Let me just be clear. Very few people ever go that extent. There's always simple steps that you could do with air conditioners, and there's even more. Testo makes a great temperature reading system. So as we're looking at the condenser unit or the compressor cabinet, again, it's the same thing, just different words. On the bottom there, we see the refrigerant line connections, so the thicker line and the heated line. We can actually put thermostats on those, and we can go ahead and figure out what the temperature difference is, or the delta on that, and that'll also tell us if the air conditioning system is working properly. But truthfully, and we don't do that, all right? I was toying with the idea of doing it, but we don't. We get enough accuracy that everything's working fine just by checking the temperature drop on the inside. Now, I'll put my hand over the top of this coil and make sure I got warm air coming out of it. But again, that's just a rule of thumb, all right? So that air coming out of there should be probably somewhere around 15 degrees over the ambient air temperature. So whatever it is, it's going to feel warm to my touch, all right? On the suction line, because we said the suction line is cold, all right, and it's going to be warm or hot and humid outside, so condensation will form on that. Sometimes there's there's insulation that's wrapped around that pipe as well, and that insulation gets deteriorated with the ultraviolet rays of the sun. So the whole purpose of that is to prevent the condensation, or I should say the whole purpose of the insulation is to prevent the condensation. But if it's outside and it's just condensating and it's dripping on the ground, I don't really see that as a problem, and I don't really make a comment on it, all right? However, if I'm losing refrigerant and I don't have enough in the system, then that pipe is already going to be much colder than the 50 degrees. It's going to be below freezing. When it gets below freezing, any condensation that forms on that pipe is going to freeze with it. And then you end up seeing this big ball of ice on the suction line. That's a pretty strong indicator that we're low on refrigerant. And usually if you're going to have it there, you're going to also have ice forming on your indoor coil as well. Now, it's not always 100% true, all right? So we always want to do our best to see what we could see. But ice on an air conditioning system is not a good thing. That usually indicates low refrigerant, all right? I like to feel that the liquid line is warm and that the suction line is cool, and just do that on pretty much every unit when it's running. So I know there's test questions about compressor cabinets being level, all right? In all reality, yeah, they should be level. I really don't make a big deal when they're not. This side is telling us we can go all the way up to 10 degrees, and it's not going to be that much of a big deal. But, if it was a piston compressor, and the whole purpose for this levelness is that the motors that are spinning, they need to have oil to go ahead and keep them lubricated. And if they're not lubricated, or the oil's not getting to them, then the motors are going to seize, and then obviously the air conditioner is going to be damaged. And the compressor is the most important part because it's the only moving part, so it's also the most expensive part, and that's the one that we want to protect, all right? So keeping it level is a good thing. However, air conditioning systems today are dealing with scroll compressors, and they don't have a tray of oil underneath them to keep them lubricated. The oil and the lubrication that they're using is actually inside the refrigerant itself. So as long as that refrigerant is moving freely, then everything's going to stay lubricated. So I don't make a big deal with it, but then if we start looking at the cost to cure, how much does it take to put a little bit of stones or another rock or a leveling pad or something underneath that to go ahead and make it level again? It's effort, it's work, but it's really not that difficult. So just do it and be safe. And to me, it's not that big of a deal, but I'm still going to document it. Disconnects on the outside are a big deal to me. there's parts of our state. I know when we were doing field training out in Illinois Valley Community College, so that was in the LaSalle, Peru area. We would use homes out there to do the field training, and it was to my amazement that they didn't really have any exterior disconnect. So that's kind of a local jurisdiction on what they're going to enforce or not enforce. At first, the first house we looked at, we come up to it, and I'm calling it out as a defect, and I'm kind of perplexed. And then I looked at all the other houses in the neighborhood, and none of them had it. So that's why I can only assume that whatever the reason is, they're allowing it. So the purpose of this disconnect, all right, it's there to design or to protect the guy that's working on the air conditioning cabinet. If he goes in there, he opens it up, all of a sudden it starts working. He needs to be able to turn that power off right away and get it there. So for me, when I look at these disconnects, if I'm in front of the unit on my knees working, I like to see a disconnect that's within easy reach, just in case the unit does start up. It's a good idea to check those connections at both ends. If they're metal, liquid tight, flexible conduit, then we can use the conduit as our grounding system. If the connections are plastic, then we're going to need a separate ground wire to come through it so that we can make sure if there's any, we can make sure that the breaker will trip should we get a ground fault on the in the cabinet anywhere. All right. So I like to check those connections and make sure that they're nice and tight and secure. And if they're loose, we got a paragraph for that too that we'll put in the report. Warm air discharges near the compressor can most likely reduce the capacity efficiency. All right, so sidewall furnaces, sidewall water heater discharges, and dryer vents. Now, the furnace, sidewall furnace discharges, I mean, the furnace and the air conditioner are not going to be running at the same time. All right, and if they are, they might be two separate units. So because of efficiency, I can't buy into that one. However, the condensation that comes off of a sidewall vented furnace, because it is a condensing furnace, that condensation is very caustic. And if that gets blown onto the fins on a regular basis in the winter, we're going to start rotting and deteriorating those fins like there's no tomorrow. All right, so that in itself, I think, is a big deal. And yeah, the air shouldn't be blowing on the fins. It should be off to the side somewhere. Water heater discharges or sidewall water heater discharges. Now that will operate when the air conditioning is operating. And we're trying to, remember, we're trying to discharge heat. So if we have hot air that's blowing on top of it, that just makes it more difficult to go ahead and discharge the heat. And direct vent water heaters are also considered condensing water heaters. Condensation does come out of that as well. So yeah, I think that's going to damage it also. And dryer vents, I mean, let's think about it. We got wet clothes that we're trying to dry, so we're exhausting humidity, plus the heat, so that could actually damage them as well. So all these air conditioning compressors and the coils that are around it, we want to make sure that we have good airflow. And then we want to make sure that whatever air flowing across them isn't going to be something that will damage the units themselves, all right? Such as the furnace, the water heater, and the dryer vents, all right? So for the most part, the fans are going to blow the air upwards, so the outside air is going to come through the coils, and then it's going to be blown upwards, all right? They can also rotate vertically and diagonally depending on the manufacturer. That's true. You should hear a hum. You should hear a minimal vibration coming out of it, but it shouldn't be loud. It shouldn't be rattling. It shouldn't be shaking. Those are all things that could tell us that we got some bad bearings or something that's getting to the end of its lifespan. It should be covered in the winter. That's according to the experts. I'll be honest with you, I never cover my air conditioner, and I don't see where there's any real damage that comes to it. And if you disagree with me, I respect that, So I do run into them a lot when they are covered. For me, it's just a pain in the butt because I need to pull that cover up to get to the data plate and take pictures of it and check to make sure my conduit is secured. And then I need to lift it up high enough to look at my fins and see if they're damaged in any which way and take a picture of those. All right. Same thing with the blower fan on top. This should be moving a lot of air so we can get that air flowing across the coil. No squeaks, no sounds, nothing else like that. I see this every now and then. Somebody will put an air conditioning coil under a deck. And again, it's only really a problem if you think that the airflow is being limited. You know, for a rule of thumb, they tell us 4 to 6 feet vertical clearance. I don't know if I could buy into that 100%. I think it would work just fine. But when you're talking about only 6 inches to a foot, yeah, that could probably restrict the airflow. Same thing on the sides, all right? When we have bushes around the outside of these things or it's pushed up against the wall of the house, then the air will flow through the other parts of the coil, but it won't flow through that part of the coil. So we reduce a lot of efficiency. We need the more air that we run through, the more amount of coils, the more efficient a unit is going to be operating. All right. The indoor coil, some people refer to that as the A coil. It only gets its name because of the shape that it's in right now. So because it's up and down like the letter A, that's the only reason why we call it an A coil. The true name, and the name I want you to remember, is going to be evaporator coil. And mainly because this is where we're converting again from a liquid to a gas. So we're vaporizing, so we're going to call this the evaporator coil. All right. The furnace serves as the fan. So the outside condensing cabinet, where it converts from a gas to a liquid, we have a special fan strictly for that cabinet outside. Inside, however, we use the same circulation fan that we use to make heat in that house. So that's our blower fan coming across. Colder air is harder to push. That's a true statement on there. So most of the modern furnaces, they're going to have multi-speed fans on them. Sometimes 2 speeds, sometimes 3 speeds, sometimes variable speed. All right. But because colder air is harder to push through the ductwork, we're going to want to increase the airflow when we're running in the air conditioning system. So as you're checking your airflow, and this is a lot of problems you're going to run into, even with new construction homes, people end up undersizing ductwork. It may be correct in the math, but it just doesn't work. All right. So when you're going around and you got the air conditioning running, try to hit every single room and make sure you got a decent airflow coming out of there. Some people, and Mark, if you're still here, I know you're going to know this answer, but some people use a wind or an airflow monitoring device, and I'm drawing a blank on what that's called right now. But they put that over the ductwork, and I kind of like that idea because now we have kind of a definitive number. And then if we have one room that's significantly less than the rest of them, that could actually be an area where we're going to have trouble heating or cooling. There's also dampers in the ductwork that we can adjust. A lot of people don't realize that in the summer months, we want most of that airflow going to the second floor and then letting that cool air drop down to change and work the thermostat. And then vice versa in the winter months. We want the hot air that we're blowing in the house, we want that to be on the lower floors because that's naturally going to rise up. All right. What I want you to remember off of this slide is that colder air is harder to push through ductwork, so I need more fan power to get the air going to the places that I want it to go to. A coil looked like the letter A, typical slab coil. We find these a lot on horizontal installs. Just one piece. So the A coil had 2 pieces, whereas slab coil has 1 piece. Anemometer. I knew you'd know, and thank you for sticking around. So just to go ahead and give Mark the credit he deserves. You know, he gave us the answer, and anemometer it is. Thank you very much. All right, so now we're back at our evaporator coil. We're going to talk a little bit about how we do our inspection. Let's get some of this text up here. And then there we go. So as we look at our furnace, we know what the temperature is via the thermostat coming into the house. If you want to put a dial thermometer on that just so you could take a picture of it ahead of time and put that in your report, there's nothing wrong with that at all. All right. I want you to remember that 15 to 20 degree temperature drop. So if it comes in at 70, it should be leaving somewhere around 55 to 60 degrees, 15 to 20 degrees difference. If you can see the coil, we're going to be looking for damaged fins, bent fins, damaged tubing. You're going to look for brown or black stains. Sometimes they'll look like efflorescent stains as well on there. Those are going to be showing refrigerant leaks in the past. Sometimes sellers know that they have a refrigerant leak in their home. And I had this happen to me a couple times. They know we're coming there. They know we're going to inspect it. They go ahead and have it charged up because they knew it leaked out on them. We go ahead and run our test. Everything's fine. My client moves in. The system leaked again. And now they need to hire somebody to get that leak fixed and recharge the system. All right. We just did a little remodeling down here at our house. And one of our contractors decided to use our refrigerant suction line to hold the drywall in, so he drove a screw right through it. It didn't make me happy when he did that, obviously. He came and ran. He said he hears gas leaking. He didn't know what it was. It was my refrigerant leaking out of my system. That ended up costing about $750. Not only that, we had to remove the drywall, fix the leak. They had to check and make sure that the leak was fixed, and then they had to put the refrigerant in there. Now, this was on a Puron system, not on a Freon system, but that's still a lot of money. And this was actually a friend of mine who did this, so that was a discount. It would probably be a little bit more than that. So finding leaks in air conditioning systems, this case I knew right where it was because we had a screw that was driven right into it, so we were able to see it and fix it. But if there's a leak anywhere else in the system, finding these things is not always the easiest thing to do, especially if the line sets or the coils, you don't have access to everything. Now, they do sell refrigerant leak detector kits out there, so if that's something you want to add to your repertoire, you can. We don't do that, but it is an option. All right. So going back to our list up here, if we're looking at the underside, we should see condensation flowing from it. There shouldn't be any dirt or buildup or crud on it, but you're really going to have difficulty seeing the underside of that air conditioning coil. Temperature drop is probably going to be our best test that we could do. Now, don't get me wrong. If we're 21 degrees, that doesn't mean, danger, Will Robinson, But if we're like 25 degrees, that's a pretty big drop, way over the line. And then I would start pushing it off to an air HVAC professional. The coil should be uniformly wet with condensation, and you're only going to see that on the underside. You're not going to see that on the top side. Definitely there's not going to be any ice buildup. If we see ice anywhere, whether it's on the refrigerant lines, on the coil itself, we're low on refrigerant. All right, so ice buildup is the number one indicator is going to be for low refrigerant. So we know we're going to be getting condensation coming from this coil. We have to collect that condensation and we have to drain it to a floor drain or put a pump someplace where it's going to go to a safe location. All right. I don't really get too much into these things. If they're going to put it into the soil stack as it shows in the upper left, you need a trap of some sort there. We don't want to take a chance for letting that sewer gas come back into the house and then now we're circulating it through our fans. It's just not a good idea. Most people, they're going to go ahead and put it into the floor drain. I have heard of one test or one question, and in fact I think we put it on ours as well, where when they start asking these questions, you got to kind of go back to the old Sesame Street stuff when we were kids. And when they said one of these things is not like the other, and talk about that. So if you see answers where the discharge tube should discharge above a sink, above a tub, in a floor drain, above a floor drain, or which one should it not? You know, above is fine. We want to have air gaps, but in is going to be the wrong answer. And we don't want to take a chance of getting any bad gases or any bad water going ahead and clogging these things. Now, the truth in life, everybody puts a little elbow in there, and then they put that into the floor drain. The problem is if you just leave it on top of the floor drain, somebody's going to come in there and kick it, and then water's going to be all over the floor. So as long as it's not in the water, I guess everything's fine. But, yeah, that's not something I go overboard with. All right. Now, if we're on the first floor or an attic install, we need to have a secondary means to protect any sort of overflows or clogs that come into play. So if we're in an attic or anything other than a basement concrete floor, let's put it that way. So if I got structure underneath us, we need to have some sort of a protection. Even with a crawl space, you have to do that too. All right. So here they're showing that we put a pan underneath it. We're going to have our primary drain, and this one they're taking into the plumbing stack. Because it's going into the plumbing stack, it's trapped. All right. And then the waters, and that'll keep the sewer gases from coming into the house. But if that primary drain gets clogged and now water's not draining there, it's going to start leaking on the floor. That's where the secondary pan comes into play. Now you'll see a few different solutions to these. Some will have alarms in them. Some will have cutoff switches. So there's little floats. So if it fills up with water, then the air conditioning system is going to shut down. Other ones are going to have another drain, but typically that drain is going to go someplace where it's noticeable. So you'll see the pipe out there. The pipe will always be out there. You should never see any water flowing from it. But if someday you go out there and you see that it's dripping out of there, that's telling me you got a problem. All right, our primary drain is clogged and water's flowing out of the secondary drain. Somebody needs to get up there and make sure that the primary drain is freed up and go ahead and drain the water as it should. All right. Now, normal flow of air, we're never going to put our air conditioning coil before our gas forced air heat exchanger. All right. That just doesn't happen. In this drawing, they're showing this as an electric furnace. All right. So you can see the electric coils on the right side, then the blower fan, and then we have our slab coil before that. So the air is flowing from left to right. Because the air conditioning coil is going to be under a negative pressure, that also has to have a trap in it. If I don't have that trap, if I don't have something that's going to stop that water from going backwards, so the air is going to be coming back in there, then the water is going to have trouble getting into it just to drain in the first spot. The air is going to keep it backing up into the pan. But once I got that trap in there, then the water's going to flow and it'll just get past it just fine. It won't be an issue. I do want to stress, though, when we're dealing with gas forced air furnaces, which is what we mostly have in our area, the air conditioning coil goes after the heat exchanger and not before. In this drawing, we're showing before, but that's mostly because it's a electric furnace that comes across. All right. And this is doing the same thing. So here they have the air filter, then they have the air conditioning coil, blower fan, and then the electric heating elements. This is very common when we're talking about electric furnaces, and again, that has to be trapped. All right. Sometimes we don't have a floor drain near us, and if that's the case, we have to put a condensate pump in there. It's going to be difficult. Sometimes you could stick your finger in there and trip the pump to see if it works. But in all reality, if the air conditioner has been running and you're in the summertime, you'd have water all over the floor if it wasn't running. So that's going to be our number one clue. But again, this is what with the forced air furnaces, what's not shown in this drawing is the actual filter. So the filter would be before the fan. So the airflow always goes filter, fan, heat exchanger, then our air conditioning coils. When it leaks, it's going to leak on top of the air conditioning, or I'm sorry, on top of the heat exchanger. It's also going to be leaking on top of the blower fan. It's going to be on the floor of the furnace as well. All these items are going to damage our furnace, so keeping that primary drain clean is important. I can't stress it enough. All right. Watch for the coil if somebody does install this upstream of the heat exchanger. Now we're going to be adding moisture and humidity onto the heat exchanger. That is going to be creating a problem. We just can't do it. All right. So again, it's filter, fan, heat exchanger, air conditioning coil. In this diagram, we're showing air conditioning coil, then the blower fan and the heat exchanger, and that just would be wrong. I made mention before on scroll compressors, and they need lubrication, and the lubrication is inside the refrigerant, and so that just constantly moves through the whole system. As it's a gas or a liquid, it's basically a lubricant as well. All right. So sometimes you can buy an air conditioning system that's already pre-charged, and I shouldn't say sometimes, they sell them today. So there's a lot of people who will purchase the indoor coil fully charged with refrigerant. They'll purchase the line set that's fully charged with refrigerant, and then also the outdoor cabinet coil that's fully charged with refrigerant. And all they do is hook up these three things together, kind of like hooking up your propane tank to your gas grill. And once they're all connected, then the whole system becomes one system again. And the refrigerant's already there. But when you do it that way, you can't cut the refrigerant lines. So you're going to have to buy a line set that's longer than what you actually need that comes in there. So there's always going to be extra line set when it comes to it. So what we don't want to do is have those coils that's showing on this screen. We don't want to have those going up and down. We want them sideways as they're showing on here. If they're up and down, then the lubricant is going to be getting caught at the bottom of these, and it's not going to properly lubricate our motor. So again, it's an easy fix. Turn them horizontally. Don't leave them up and down.